Thank you so much for joining me today. My name is Dinesh Chandrasekhar. I'm with CLOUDERA. I run product marketing for the Data in Motion BU, which is all about streaming data, IoT, and all the related use cases around it. In this session, I want to address primarily around IoT edge management and the challenges around it. So IoT, as you know, is a space that is like exploding like crazy. Every single vertical has got like tremendous amount of use cases. And we have solutions that cater to some of the challenges into it. But even before we get into the solution space, let's talk about some of the challenges associated with edge management. So edge, as you know, is a pretty broad, loosely used term, and it means different things to different verticals. So I want to make sure that we define what that edge is, where the devices are in various different types of use cases, and what are some of the management challenges that are associated with that when it comes to data collection happening at the edge, and even when it comes to like managing specific agents that are sitting out at the edge as well. So let's get into a little bit more deeper. So let's set the context first. So there are plenty of use cases across multiple industries when it comes to IoT, right? We talk about predictive maintenance in the case of manufacturing. We talk about patient monitoring when it comes to healthcare, and so on and so forth. But every single one of these use cases talks about a mechanism through which they are collecting data from these endpoints, right? In the case of predictive maintenance, you're talking about IoT sensors attached to machinery on the manufacturing floor that are collecting inputs like temperature, humidity, fluid levels, and so on and so forth, vibrations, shock sensors, and all that. And then when it comes to asset tracking, you're looking at geolocation monitoring, where that particular asset is in any given point in time and all that. So there are different sensor types, different data points that are being collected at each one of these areas. But when you start looking at these broad set of use cases, a few things start emerging in terms of trends, in terms of commonality. One is that data needs to be collected from all these different sensor types, right? So there is all these sensors that are out there, but the data that is being generated from these sensors need to be captured in real time and need to be sent out to analysis system, an analytics system that needs to understand what the data actually means. And this could be your data lake, this could be real-time stream processing systems, this could be analytic solutions. So any one of these pockets pretty much understand what the data actually means in real time and tell you what that actually matters in terms of business value. So in the case of predictive maintenance, let's say, for example, a particular asset is like heating up. You detect a particular temperature trend. That particular values of real importance in real time at that particular moment, so that operators can look into it and like fix that particular problem, right? So to be able to get that value in real time is one of the key requirements of this particular use case, and so on into patient monitoring and every other use case that you can think of. When you start highlighting this, then you start realizing that the commonality extends into devices sitting out there that are monitoring it, data that needs to be collected, and also the fact from an operation standpoint, wanting to understand how many such devices are deployed, which ones are functioning, which ones are not, and also to be able to like make specific updates into those edge devices. So this is where the real set of challenges start emerging when it comes to edge and edge management. So then let's start defining what is the edge. The edge means different things to different verticals. In the case of the manufacturing example that I just said, it could pretty much mean the manufacturing floor where these IoT sensors are deployed on those machines. In the case of healthcare, these could be the IoT devices that are sitting inside hospital rooms monitoring patients that are looking at specific metrics like blood pressure, oxygen levels, and so on and so forth. So every single vertical you start looking at it, the edge means different things. And then you start elevating the conversation, you talk to vendors and you say, hey, what is your edge, or what is your definition of the edge? And some of them could come back and say, well, our level of the edge or our definition of the edge is at the gateway level. So then you start wondering, what is the gateway? What does this got to do here? So then you start laying out a reference architecture to figure out where things sit, what each and everything means, and what the edge actually means to different people. Devices sitting out at one particular area where you have the actual data collection happening. All those data sensors are transmitting data into the enterprise for processing. And as they're coming into the enterprise, there is a gateway. The IoT gateway or the security gateway that is collecting all these data. There's like understanding that these are coming from valid devices that have been authenticated, authorized by the particular enterprise, and that data can be processed into the enterprise. So that allows that transmission to happen through. Once that data gets into the enterprise, then you have needs for stream processing, streaming analytics, and all that process the data to gain that real-time insights. So now you start looking at the edge. It could pretty much be the devices that are sitting out there. It could pretty much be in the gateway based on how you define it, because you may not have control over the devices. All that you care is like the device data itself. So then your definition of the edge starts moving around. But predominantly, for the sake of the conversation today, we'll assume that the edge pretty much means the device is sitting out there where you're collecting the data from. So if that be the definition of the edge, then why is edge data collection so important? And then we'll get into the challenges. So first one is need for real-time insights. As I said, there is a notion of data decay when it comes to IoT. There is a moment in time within which the data is of utmost importance, after which it starts decaying in terms of value. So in the case of a patient monitoring example, if a particular abnormality is detected on that particular patient based on the sensor data that you get, within that time window, if you are able to alert a healthcare professional automatically and say, this particular patient requires immediate healthcare assistance, that is an opportunity window for you. That is where the data is of utmost value. That is the real-time insight right there. But if you're not doing that, if you're saying 4 hours later, 6 hours later, and you're saying something went wrong there, that's not of value. You lost the patient, or the patient went into critical condition. That is not helpful. So to be able to utilize that data in real time is of utmost importance, and that's why need for real-time insight is critical. So then you might ask, okay, if that be the case, then I can pretty much capture all the data, right? In a large set of enterprises, when we start talking about IoT, or people have said, oh, we already do IoT, the question when we start probing saying, how are you processing the data? How do you define real-time insights? The most common set of responses that come back is, we collect all the data, we put it into our Oracle database or SQL Server database. There's the ETL process that runs overnight. And then next morning, we are gaining insights into what that data means. Well, that's 7 or 8 hours later, and you're already lost the real-time value of it. So in a sense, that's not what the intent of making IoT initiatives successful actually is, right? The intent is to get those real-time insights, to act upon that in real time. So then ETL processes are not really real-time in this particular case. The last thing I want to emphasize is data provenance. So in today's age of security breaches, GDPR and those types of compliance regulations, everything popping up, you want to be able to be really, really sure of where this data originated from. And in the context of IoT, there are multiple devices that you set out there. Nothing is stopping a hacker from getting to your enterprise, feigning themselves as one more device, and saying, I'm sending you data, right? That's a very easy way to hack into the system. Of course, there are security measures that are being put in place. But to be able to clearly know where this data originated, what changes were made to it, how is it getting into the enterprise, who touched it. So all that is very critical. So data provenance is something that is often overlooked in the context of edge data collection and streaming data. So I want to mention that that's also something that you need to factor in. So let's start defining this is not how the animation should have started, but okay. It starts off with the right, it should have started off right here. I don't know what went wrong with the animation, I apologize. But we'll start defining a little bit of a streaming reference architecture. What I mean by a streaming reference architecture is this is very typical of an IoT use case that is out there that enterprises and other types of verticals within implement. In this particular case, we are talking about a fleet management concept where you got, as a company, multiple types of trucks that you're managing, and all these trucks are plying all across the country. And you want to be able to understand specific metrics about the trucks. This is around how fast the driver is driving, speed sensors, geolocation, right? So to capture where the particular truck is, to know exactly whether the truck is stopped somewhere, it is in an accident, or if it's moving from point A to point B. So to know that. And also to understand various health of the truck metrics, brake levels and this and that, all that kind of metrics as well. So once you start looking at that, then you say, okay, I got sensor devices that I've attached to all these different points in the truck. I can measure what's going on. And I can do that for different regions across different types of trucks. I can define a class of trucks made by a specific particular manufacturer. In this case, I got Freightliner trucks, I got Mack trucks, I got Tata Fleet trucks, right? I'm a big fleet management company, so I got all these different classes of trucks. So I have all these sensors there. Now these sensors are sending in data. Now we talked about a gateway, right? There is also a concept of an ingest data gateway, right? Where all these sensors are coming into the enterprise. through some kind of a mechanism that is like streaming it into. In this particular case, I got like a bunch of Kafka topics. And Kafka is like very commonly used in these types of reference architectures where it allows you to scale. Because it's like a pub-sub messaging platform, publish subscribe kind of a platform, it lets you like pump as much data as you want into it, you define the retention periods of that message in that particular platform, and then allows for subscribing applications to pick messages off those topics. Once you start getting into the enterprise, then you start defining, okay, how do I process this data? How do I get all this data and refine it? So then there is a data ingestion tooling that you'll need. In this case, we are talking about Apache NiFi. And Apache NiFi is a highly scalable data ingestion engine that allows you to take in data from such IoT sources and be able to process that, refine that, do any kind of simple transformations that you need, and then push that further into any subscribing application. In this case, this could be another set of Kafka topics where there's content syndication happening, right? And then finally, there is like a lot of analytic solutions that could be feeding off of such real-time data, providing these kinds of predictive analytics that you require for IoT in general. So this is like very typical of a streaming reference architecture, right? In this particular thing, I want to point out that one thing kind of that I overlooked there at the very beginning when I started talking about data collection is that you have different types of devices and sensors on all these trucks. But what we did not talk about is how does that device send the data out? What is it that is making the data to transmit from those trucks into the enterprise? And that's where we start talking about edge agents. Now, edge agents are runtimes that you deploy out in or near the devices. And these sit out at the edge, communicate with the device, establish that connectivity, and are able to get that data out from those devices and can process that right there. So now we are in the age where we are talking about edge computing, edge intelligence, so many different advanced topics. I'm defining the very fundamental of edge and IoT, which is to collect data from the edge, right? The subsequent advanced topics come in a little later, which is where you start talking about how do I do, process the data right there? How do I, create analytics right there? How do I provide machine learning models out there and all that? So we'll get into that. But let's first define what that means, right? In the earlier picture, you saw me have like little logos that were called Minify. And I'll get into more detail on that. Minify is like a small, lightweight agent. It's like a subset of what NiFi offers. It's got pretty much the same power and the processing capability like what NiFi does, except that it doesn't have a user interface like NiFi. And Minify comes in like a couple of flavors. It has a Java flavor as well as a C++ flavor, allowing you to embed this in any different type of device or operating system. So these edge agents can then communicate with the device over different types of protocols, MQTT, CoAP, and whatnot, and be able to get that data and able to transmit that data into NiFi and Kafka and all that. So that's the way the communication pretty much happens from edge to the enterprise. So if that be the case, then let's start talking about what some of the key challenges at the edge are. First one is, how do you deploy these edge agents, right? So you have a scenario like a trucking company that we just talked about. I got several thousand trucks that are plying out there. Each truck has 5 or 6 different sensors that I want to be able to monitor. I want to be able to get that data. How do you get those agents into such devices or near the devices? That's one thing. So the deployment angle is a key thing that needs to be understood. I'll get into more details of how we solve this. Identifying classes of agents. So I started pointing out saying I have a variety of trucks, right? So I've got Freightliner trucks, I've got Mack trucks, Tata trucks. I want to be able to segregate that. I want to be able to not just look at all my 3,500 agents out there as saying 3,500 agents. I want to be able to say these sensors or these agents are meant primarily for these types of trucks because they come from a specific manufacturer. They have a different device operating system. They have a different set of device data points that they generate. So everything is different from different manufacturers. So then you start looking at, okay, how do I define those classes? And it'll be important when you start talking about updates. Because when I start pushing updates out to these specific classes of agents, I might want to make different things to different setups. Like, for example, if there is a specific set of trucks from where I want to collect a different set of data points, unlike the other set of trucks, right? Because these are the trucks where they're flying in like really bad weather conditions. So I want to probably measure how long the truck has been idling, how long the truck has been flying, where does it travel, geolocation and whatnot. So there are specific sensor data points that I want to collect from only a class of trucks. How do I push that kind of update into those trucks alone? Then the other thing is about device compatibility. We talked about it. I said Minify comes in like Java and C++ kind of flavors. Then how do you make sure that these agents are compatible with those devices and you're able to deploy them? The other aspect is also edge storage. So there are use cases, really interesting use cases, like airline engine manufacturers that are embedding different types of devices in there, sensors in there. And they want to have different types of agents monitoring or connecting, communicating with these sensors to be able to get that data. Now, when the plane is actually flying 35,000 feet up in the air, it's not going to have any kind of communication back to ground base to send these data points. I mean, there are only specific types based on the airline protocols, FAA protocols and all that. Only specific data points can be communicated out, not all of it. So if you got 100 types of sensors on an airline engine right there, it is collecting data while it's flying. It is able to measure and monitor. It's able to collect all the data. But it may not have the transmission capability, which means it's offline in a way. It needs to have a local storage. It needs to be able to store that data right there into that storage area. And once it lands at an airport, that's when it starts communicating. And it may not be fully complete as well. It might pull out of that particular gate in 20 minutes, which means the communication might be halfway through. It might be cut off, and the next time it syncs up at a different airport, then it starts syncing up again. So these are the kinds of challenges that you'll have in specific types of use cases as well. Last thing is low power. We start talking about edge. We start talking about different type of use cases. Most of these have one common requirement. I'm a small device. I'm sitting out in a particular moving target, like a truck or something like that, and I don't have much capacity in terms of processing power and all that. All that I want is something that can run in a small footprint, that can run really capable, and doesn't consume a whole lot of power. So that's one of the requirements as well. Which means your edge agent cannot be humongous. It cannot be running a GPU kind of processing power. You need something quick and nimble that can do this. So then that brings us to a key topic. How do you manage all this stuff? Edge management, right? You got edge agents. You started talking about edge data collection. But then the management problems start emanating, right? You need to be able to understand how many agents are deployed out there. How do you communicate with them? How do you send these updates? How do you know something is up or down, right? So then comes the notion of edge management hub. A hub is primarily a single central management monitoring tool that pretty much knows your field of agents that are deployed out there. It's able to communicate with them. So that is kind of number one in terms of requirements. Second thing is application support. So to be able to execute some logic on the agents is something that is powered from this management hub. So the agent by itself is not aware. It's not smart enough to know I need to be able to get these data points from this particular sensor. What is required is for it to get instructions from a hub. The hub pretty much lays it out saying, here's the program of what you will need to do, communicate, connect with this particular device, do all these transformations, do any kind of ML model processing or scoring that you need to do, execute that, and then push that data, the process data, out to here, right? This program instruction is something that is set up at the hub level and can be pushed out to specific classes of agents. Over-the-air updates, that's also something that's possible. We talked about network connectivity, offline stuff and all that. So to be able to say, I can push the program instruction from the hub into a particular area. The agents, whenever they come back alive, whenever they connect up back to me, can download those changes and update themselves. To have a registry is also kind of one of those requirements, to be able to know how many different types of agents are out there. And that allows you to have that bidirectional communication as well, to be able to know, yes, I have agent ABC out there. They are my agents. I know that because they are authorized. I have their ID and everything registered on my registry. And they also know to pull updates and everything back from the hub whenever the hub says I got new changes. Last thing is eventing. Every single agent out there is going to have some kind of an eventing model. It's going to create events. It's going to say, I started up, because my device was like rebooted, so I started up, right? So that's an event. It's going to say I connected up with this particular device. It's an event. It's going to say I collected all these agents. That's an event. So everything is an event model. And for you to have that kind of eventing model, it's kind of beautiful because now, based on these events, now you can trigger certain things. Like, for example, if you say a particular sensor that not generates like, data points like every few minutes, but it's probably generating like once every couple of hours or something like that. There are sensors like that. There are use cases like that. To be able to allow that eventing model to like trigger specific programs, specific instructions to fire off is where the power of eventing will come in handy. So when you look at managing edge data collection, looking at the same streaming reference architecture, a few challenges in terms of edge management comes in play, right? One is, how do I develop these kinds of programming instructions and all that? In our world, we call it flows, data orchestration flows. So data orchestration flows are pretty much like visual drag and drop kind of a way to build these programming instructions that I was talking about. It's a very simple way, no-code way to define that, and you can do that with NiFi. So similarly, in the event management hub, you can do the same thing, and to be able to define that, and to be able to push that out to the agents, how do I do that? How do I deploy that to the edge, right? And then I can also be able to define and deploy that to a specific class of trucks, as I mentioned earlier. Last thing is to be able to manage and monitor these hundreds of thousands of agents that are out there, and to be able to know that they are actively running. So these are all like different data collection challenges. And then from a data edge management challenges standpoint, there are some key things. So one is network availability, right? Not all the times you are like connected to the network, which means the edge agents are probably collecting some data, but it's not able to like communicate with the hub right away, which means it's not like transmitting data. So there is a notion of like local data storage, or maybe like holding onto it in some kind of a buffer mode, and to be able to like transmit that eventually when the connection is established with the hub. Offline storage. So this is kind of related to that topic where you want to be able to like store the data until you establish communication to be able to like respond to that. Agent heartbeats. This is also critical when you start talking about monitoring different types of agents. To be able to know that the agent is alive there. The device might be up. The device is probably generating it. For some reason, maybe your agent crashed. But you would not know that unless and until the management hub is having some kind of a heartbeat sensor with the agent to like know, yes, I got that event from that agent. I got that heartbeat event, and I know that that particular agent is alive. So let's talk about a solution. CLOUDERA DataFlow is a data in motion platform that we have. And I want to like kind of keep it at a high level so we kind of can stick with the theme of the topic of like edge management challenges. The way we look at the data in motion platform is looking at it from a data journey standpoint. You start at the left and then go to the right, where you collect data from the edge, and you're able to transmit it all the way into the enterprise for real-time insights and all that. Edge management is like fundamental here, right? So edge management is where you start talking about three different things. One is minify. Minify is the agent architecture that I talked about, right? And minify allows you to be residing at the edge inside C++ agents, Java agents, and all that, as C++ agents or Java agents, based on what the target operating system is or target device is. We also have an event management hub, edge management hub called EdgeFlow Manager, which is very new. It's getting announced only next week, so you're kind of sneak preview for you in terms of information. So EdgeFlow Manager is allowing you to like look at all the different agents that are deployed out there, all the minify agents. It can manage and monitor that. It can do all the different things that we talked about in terms of the needs of event management hub, right? To be able to like design visual flows, to be able to like push those flows to specific classes of minify agents, to be able to like do over-the-air updates, to be able to like create a model where the agents can pull in the changes from the EFM hub when and wherever needed. So those kinds of capabilities are available. And then as we start looking at to the right, as the edge starts pushing the data, the data collection starts happening, flow management is kind of primary. This is where we start talking about enterprise flow data ingestion. So all these streams of data coming from different types of IoT devices now can be ingested with Apache NiFi. And Apache NiFi allows you to like do this kind of, again, visual flow modeling of being able to do data orchestrations, knowing where to connect from, how to get the data, process that, do simple transformations, and then push it into subsequent streams. And the subsequent streams being Kafka. Kafka is, again, very omnipresent in a streaming reference architecture, as we saw earlier, because it allows you to scale like that. It allows you to like not only communicate and get data from NiFi, but also from other sources. Because it's a pub-sub architecture, it doesn't like, inundate the end consuming applications, because the end consuming applications can subscribe at their own pace. So that is a model to scale. And Kafka also ships with NiFi schema registry that allows you to like send messages from point A to point B without having to embed the schema inside the messages. The registry holds the schema, and then the schema ID can be used as a part of the headers inside the messages, making it more lightweight and more scalable. And then as part of the streaming analytics, the real-time need for looking at insights, that's where you start talking about Kafka streams, Spark streaming, Storm, and different types of streaming analytic solutions that can look at those real-time data points, that can provide real-time insights, actionable intelligence that we need in an IoT context. We talk about it as a platform because there is a broad set of enterprise services that cater to like making it provide like seamless single security, unified governance, and all that. And again, provenance is a key thing for us. NiFi provides it out of the box. But to be able to like carry it through, we got these enterprise set of services to make sure that that governance model is established throughout across NiFi, Kafka, and so on. So I want to like kind of jump into each one of these real quickly so you kind of get a flavor for what these actually mean. Minify, as I said, is a lightweight version of NiFi. Right? It's got like 2 different flavors. It's a much smaller footprint. The C++ flavor is only like 6 megabytes or something. And so it allows you to be embedded like in devices like Raspberry Pi, Intel Movidius, and all these different types of cards and devices. It's got the same kind of processing power and capability like NiFi. And it's got TensorFlow support as well, which allows you to like embed ML models in there to be able to execute that right there inside the edge agents. It is primarily designed for IoT, but you can use it for other types of use cases like tech ops, where you're ingesting log data from like, let's say, 50,000 machines, and you can embed like agents across all these different machines and have Minify collect the data, process the data, and then send that data back into the enterprise as well. So as I said, this is like the new component that we talked about, right? CLOUDERA Edge Management. And don't tweet about it until next week. But this is about offering this combination of Minify agents and this edge management hub called EdgeFlow Manager, and to be able to give that combined offering of helping you realize the value of IoT, to be able to deploy those agents, to be able to like measure and monitor and do these different types of updates, and that makes it even more powerful. And it has that visual modeling capability to be able to do the same things like what you were able to do in NiFi that you can put in there. Talking about NiFi, this is the kind of interface you get. I mean, this is like one of those really slick tools. It was originally created at the NSA, and we acquired it through an acquisition over the years. We meaning like Hortonworks did that, and then now CLOUDERA being Hortonworks and all that. So we pretty much are the safekeepers of NiFi. We got one of the writers of NiFi sitting right here, committers of NiFi sitting right here, Andy Lopresto. So very honored to do that. And we, pretty much the core team of NiFi is with us. The entire team that wrote this is with us, which is making it even more compelling. There's a significant community out there that is using NiFi. Customers are raving about it. And I keep emphasizing on this because this is kind of critical when you start talking about the whole edge data management, right? Edge does not stop right there. It extends into the enterprise, and you want something as powerful as this to be able to communicate with these edge agents and get that data into the enterprise. It has over 280 plus processors that allow you to do deeper ecosystem integration, right? Getting data from like multiple different types of sources to be able to push into different types of, so it's like any to any kind of a model. But more than anything, it also does transformations and all that you require on the data enrichment, to be able to look into other types of data sources, to be able to get that data, augment that, do any kind of transformations you need, and then push that into subsequent streams. Kafka, on the other hand, is pretty much everywhere, right? We talk about it as being omnipresent. This is how the other slide should have built. So Kafka is everywhere. It is critical for streaming reference architectures. But the more and more we see Kafka coming up as it's growing, we also see that there is complexity involved in Kafka. And Kafka is essential, again, in the IoT context, because you cannot get away with it by saying, I got all the data in, but then your endpoint systems are struggling to process the data. You need something as powerful as Kafka to manage millions of messages per second. And so Kafka, the more and more it starts growing in terms of nodes and clusters, you will see that there are plenty of visibility challenges in terms of operations, in terms of development, and all that. So we ended up creating this Streams Messaging Manager solution that is primarily a view into Kafka. It allows you to look inside the development aspect of it from an end-to-end flow standpoint to be able to visualize how the data is progressing inside your Kafka streams, to be able to know whether your broker, Kafka broker, requires additional disk storage or not, to be able to know if a broker is up or down. So from an operations standpoint, from a security and governance standpoint, as well as from a DevOps standpoint, you get complete visibility into Kafka using a tooling like this. There is nothing out there from an open source standpoint or from a proprietary standpoint out there. So this is very, very powerful. A lot of our customers are raving about it. Last but not least, the streaming analytics aspect of it. So we got different flavors of analytic solutions available. And you can pick and choose, right? That's the power of the platform, where it allows you to integrate with different types of analytic solutions to get those real-time insights for your IoT initiatives. And when I say real-time insights, we are talking about pattern matching, complex event processing, and so on and so forth, to be able to gain those real-time insights into that. And one of the common things that we also see is that Kafka, as it is growing in terms of streaming reference architectures, the retention period inside Kafka is also being extended. So instead of being a few minutes or a few hours or something like that, now we talk about customers that are saying, I want that data to be residing inside Kafka for a couple of weeks. So that makes it in that in-between state where it's not landed in a data lake, but it's still real-time data, and you want to get that real-time insight into that Kafka data. But how do you look inside Kafka when Kafka does not provide an out-of-the-box UI by itself? So that's where we provide 3 different types of streaming access patterns. One is through some of the analytic solutions that we saw, like Kafka Streams and all that. 2 would be using Hive Kafka SQL, where all these Kafka topics can be mapped as Hive tables. And you can directly query those Hive tables as SQL and look inside Kafka data live. The third aspect is to be able to map those Kafka topics as OLAP tables and to be able to query that using any of the BI solutions, the dashboarding solutions that you want, because these are OLAP cubes now. So this is again, taking the data decay concept very importantly, and to be able to address the challenges associated with real-time streaming reference architectures, to be able to look inside something as complex as Kafka with as much ease as is required. The last thing is the enterprise set of services, right? As I said, it's a platform. Everything is connected and integrated very, very well. And so to be able to give provisioning capabilities, management, monitoring capabilities, security, and governance end-to-end, we call it edge to enterprise, to be able to go all the way from edge to enterprise and still have that same model across, is what we talk about in terms of enterprise services. So with that, I want to pause, and I want to throw it open and say, if you have any questions, I'll be glad to address that. I hope that was insightful into the edge management, edge data collection, the challenges associated with it, and then a solution that we have that addresses those challenges as well. So, questions? Don't raise your hand yet. Already raised your hand. Nobody's asking questions. Are we good? Awesome. Well, thank you so much for coming in. I appreciate it, and hope it was useful. Feel free to reach out to us for any other questions, and I'll be happy to help.